Hi there, boys and girls. This is going to be a beta demonstration or a testing demonstration of the SANS calculations as we've built them into Revit. So please understand that it's a system under work, under construction as it were. So there might be a couple of issues that we still need to sort out, some formatting, terminology, so on and so forth. But I'm hoping for sort of the end of January 2012 to have the system fully up and running and get it into your hands. In order to successfully do that, I'm going to need a little bit of input from you guys, so please take the time to watch this video, read the articles on the blog page, and then comment. If there's something you want to see done differently, if you have any questions, queries, comments, suggestions, please make them. The more of those I get, the more of those I can build into the actual system, the more efficient it'll be when it finally gets into your hands. Just in terms of a little bit of background, for those of you who are not quite familiar with the SANS calculations just yet, these are set out within the SANS documentation. Effectively, it's a system of a certain amount of allowance for the conductance and solar heat gain for both naturally and mechanically ventilated areas. Once you calculate your allowances, you then need to have a look at the actual model and determine whether the modeled elements meet those deemed to satisfy requirements. If they do, great, Bob's your uncle, you can submit your plan. If not, you've got to do a certain amount of rational design or change your model to fit in with those. Some of these calculations, as you can see over here, can get pretty complex. A lot of lookup tables and values that are dependent upon other calculations, which, at the end of the day, we've managed to build into the Revit template. My biggest goal with regard to this was to make sure that these calculations form part of the BIM model. I know that there are a certain number of accredited or approved calculators out there. There are other software packages which also have the calculations built in, but I have not yet come across one that is actually linked to your model. You guys are either using external sort of Excel-based calculators where you manually have to input the info from your plan, or the information from your drawing, from your plain 2D CAD drawing, gets outputted to a text document. The problem with that is obviously that it's not linked to your actual drawing. If you update the drawing, you've got to re-update either that text document or re-input the info into your Excel spreadsheet. I've tried to do that differently so that your calculations are updated as much as humanly possible inside of Revit. Take a look, let me know what you think of it. Alright, here's the system in place, and here's the challenge. I'm going to work using this Revit template, which already has the appropriate schedules built into it, which effectively is the system that we're implementing at the end of the day. And I'm going to just spend a couple of minutes quickly creating a Revit model from an existing CAD sketch. Add the appropriate BIM elements and then see what my calculation results are from this model. As a challenge, I'd like you to either perform or consider the amount of time it would take you to get your results as far as I'm going to get mine in under 10 minutes. Whether you're using an existing 2D CAD based system in whichever format that is and however it spits out the results at the end of the day, or an external calculator built into Excel or something like that. I'd like you to consider the amount of time, and perhaps even if you can, test out the amount of time it takes you to spit out the level of results that we're about to get in the time that we're going to spend on this model. Thereafter, at which stage I presume I'm going to leave just about every other system behind, I want you to have a look at the amount of time it takes for the changes that I effect to the model to be updated in terms of my calculations. I have yet to see a system that's going to come even remotely close to the speed with which we're going to update here, because obviously the updates are going to be instant. Alright, so here's my model. Just a simple little townhouse. I think this is about 160, 170 odd square meters. I've probably got what would be a ceiling level here, which is a little bit high, so let's just go and drop that. Okay, I'm not going to add too much further detail to this model. Now, what I need to do first and foremost is do the calculations for the area-based allowance, in other words, for naturally ventilated buildings. I don't have to manually click in the corners of the areas to define my rooms. I can simply just use Revit's automated tool. What I do need to do is tell it which zone these rooms are in, which I've just done again by means of a parameter that I've created here, which currently has just one value. I've based this template upon zone 4. We'll work on the templates for all the others and easily add those additional values. Alright, so there I've created my individual rooms. So if I now go and have a look at my allowance schedule, there it simply calculates it out. You can see 181 odd internal area there. Okay, so notice my values here for the conductance and the solar heat gain, 253 and 23. If I simply go back to my plan and I make an alteration to the model, the building becomes bigger. There my allowance schedule updates. Instant result. No need to change anything other than just move a wall. Alright, you can manipulate the schedule further, for example by turning off each instance so you just get an overall result, or you can leave those rooms on individually to double check your work. You can also filter it by level, so if you had a multi-story building you can create a schedule for each of those levels and get your allowance in that way. Alright, the next one that I'd need to potentially measure would be my facade area, which will help me determine the allowance for a mechanically ventilated building. Alright, I've pre-created a gizmo which we're going to use for this kind of calculation, and a set of elevations which helps me highlight that gizmo. Right, it automatically picks up the levels, the gizmo that you simply place over there. All you would need to do is just lock it to the extents of your building. Alright, that gizmo can then simply get a comment which can say, listen, this is the facade area gizmo which faces north, and if this was a multi-level building I could say it is number 1, so it's referencing that level. As soon as I add a comment to it, you'll notice how it's highlighted in purple. In wireframe mode you'll see it run all the way through there, so it clearly demonstrates the facade measurement. I can, if I want to, add an additional level down here which references an actual ceiling level if it was lower than what is effectively my wall plate level, but for now we'll just leave it like that. Alright, that would then in my scheduling give me my north facade area. I could add it to the additional north walls. I'm not going to complete this model entirely now. This is just to give you an idea. Alright, so it automatically calculates that. The advantage once again of doing this inside of the Revit model is that if at any stage my facade changes, so this becomes shorter, notice how my gizmo changed as well because it was locked to the extents of the building. Alright, so no need to manually update any of the info that sits inside of your model. The next step would be to start placing doors and windows and then actually see what my energy usage is going to be based upon my fenestration. Alright, again I'm just going to go and use standard windows here for this exercise that I'm going to place in all of these rooms, and I'm just going to make them the same size because we can change one or two of them later on and then go and see the actual result. Now these windows are nice and easy to select, and by means of your Revit filtering you can limit your selection to just the windows, because I need to give this a glazing description which comes from the SANS document. I've broken these down into view orientation, so north, east, west, south, so on and so forth. And I'm going to say, listen, this is an aluminium or steel frame window in a northern elevation, and it uses single clear glass. As soon as I select that, all of the windows get the appropriate information filled into them. Alright. At this stage, because it's a uniform building, I can also say, listen, the P value, in other words, my overhang, is 600 millimeters. So I can fill that out. At this stage, if I knew the G value, which is the top of the window to the bottom of the overhang, I could input that as well. I'll just say, listen, that's 200 millimeters, and I fill that in, which means I can now go across to my window schedule, and then my calculation is performed. My total allowable conductance for those windows, as well as my total solar heat gain. The calculation is instantly performed. So it becomes easy for me now to go and have a look at my allowance next to my actual usage. Alright, so my conductance allowance is 258.71, and I'm currently on that much. Simple as that. Okay. I can at any stage decide to go and make an update to the model. So for example, if I now go back to my plan, and I know, listen, these two windows that I've got over here actually belong in bathrooms. So if I just create duplicated copies of them and then just change their sizes, let's just make them 1200 by 900. Okay, and then I'll just sort out the header. It's 2125. Alright, having a look at that actual elevation, there we go. I've made them a bit smaller. These windows, these Yankee windows, that sit at such weird levels. Let's just sort them all out. 2125. There we go. Alright, so having changed that, if I now again go and have a look at my schedule, you'll notice that the area for those two windows over here has updated, which would then obviously follow through to my actual calculations that have been updated. Simple as that. If I scroll all the way to the end of my schedule over here, you'll see here's my aggregate air conditioning energy, which is for a mechanically ventilated building. There it updates. That again I can go and compare to my allowance schedule over here. And if I wanted to, I can again place these two next to each other and get a live result that I can compare to my allowance. So my energy allowance was X amount. I'm currently using that much, so I know, I need to go and sort something out about my design. Alright.